Hello, let's continue our Sudoku journey with intersections by Awesome Sauce. So we have done this constraint before, the sequence lines constraint, but let's go over the rules. So we have normal 6x6 Sudoku rules. So in every row, every column, and every 2x3 box, we are putting the digits 1 through 6 exactly once each. Additionally, these lines, they do go straight through, by the way. They go through intersections. So this is one line, this is one line. On these lines, we're going to have a sequence of digits in order with a constant difference. So for example, this could be 2, 3, 4. That's in order with a constant difference. That would be fine. All right, so those are the rules. And if you check the description, there is a link to try it yourself, and I am going to try it right now. All right, so I think an important observation about sequence lines is the middle digit can't be a 1 or a 6. And the reason for that is, let's use this one, for example. Let's use this one, for example. If this was a 1, on one side we could go 2 or 3 or whatever, but on the other side we'd have to go below 1, and that's just not going to work. Same with 6. On one side I could go below 6, but on the other side I'd have to go above 6, and that's also not possible. So this isn't a 1 or a 6, for example. And if we look, this one looks over, this one looks up, and this can't be a 1, so that does place a 1 here. All right, so these ones look down, placing a 1 in one of these two. I will look to see if this can be a 1 in a second, but let's see if there's any other low-hanging fruit. This 2 does look over. One of these two is a 2. And I can already tell you this one's not going to be a 2. Because if this one was a 2, then we need a 1 on one side of it, and there's a 1 looking at this whole line here. So this is not a 2, so the 2 goes here. And so now this is either 2, 3, 4 or 2, 5, 7. It's not going to be 2, 5, 7. So we are 2, 3, 4. That's helpful. So if this was 1, this would be 5, and I think that works fine. How about this digit here? Because it's in the middle of a sequence that can't have 1 or 2 on it. And this can't be a 3 or a 4. So this is 5 or 6 only. So we could go 6, 5, 4. Can we go 6 down to 4? No, because then we'd have to go 6, 4, 2, and 2 is used up. Or we can go 5, 4, 3. Can we go, but we can't go 5, 3, 1 because 1 is used in the column. So that's how this turns out. So it will be in order. So this is going to be the 3 or 6 that isn't on this line. This is also 5, 6, by the way. And we need a 1 and a 3 here. All right, how do we want to continue this? Well, maybe this line here is interesting. Maybe. I'm not seeing a huge amount of restriction here because we don't know which direction it goes. So there's probably something better to look at. How about up here where this needs to be 4, 5, 6? So this cell's not going to be 6 because 6 to 3 you'd have to go to 0 afterwards. So actually, this is either 1, 3, 5 or 2, 3, 4. I don't know if that's helpful yet. How about this cell? If this was a 1, this would be 2, and this would be 3. That does work. If this was a 3, we could go 3, 2, 1. No, we can't go 3, 2, 1 because 1, it can't be here. So if this was a 3, we'd have to go 3, 4, 5. All right. How about this way then? So if this was a 2, I think that's problematic because this can't be a 3. And we can't go 2 to 4 because this would have to be a 0. 2 needs a 1 on one side or the other, and it's not going to get 1 on this line. So this is not a 2. This is a 4. This is now 5 and 1. Nice. These aren't 5. 4 certainly isn't repeating on this line, so that's 6 and 4. Now we just do the math to see that that's a 2. 4, if it had 3 on one side, it would need 5. That seems to work. But 3 on this side would need 5 here. So this is a 5. This is a 3. That's 1. The last one goes there. Okay, so this is a pair. This is a 5, 6 pair. So if this center cell were a 5, then this would be 6, and this would be 4. But this would be 6, and this would be 4. These would both have to be... Okay, so these sequences, I think I probably may have been able to see that earlier. That's actually really clever. But I'm seeing it now, last second. But these two can't be the same digit, which means these two sequences, one of them is difference of 1 and one of them is difference of 2. So one of these needs to be 2, 4, 6, and this can't be the 2, 4, 6. So this one's 2, 4, 6, and this one's 3, 4, 5. And that should finish the puzzle up. This one's a 5. 3 and 4 go in here. How about over here? We need 3 and 5. Those go like this. I need 2, 4, 6 over here. This is the 4. I think this is a 2, 6 pair right now. Oh, this one we can finish though. This is a 2. There we go. This is 6 and 2. And I need a 3 and a 6 here. They go like that. And there we go. All right, cool puzzle, awesome sauce. I enjoyed it. I liked this bit here, and I wish I'd noticed that earlier, although I didn't have to. Often, instead of doing something complicated, you can do some Sudoku first and make it a little bit easier to think about. But still, this was neat, where these two digits not being able to be the same means that we had to have two different differences of sequence, because the middle digit is shared, right? So if these two are different, these two are different, is basically what that means, and that finished it. So that was neat. Thank you very much. And if you enjoyed the puzzle, let me know how you did in the comments. And of course, why not leave a like and subscribe?